Mathematics Level 4, Topic 4, Module 2. Topic 4, Data Handling and Probability Models. Module 2, Variance and Regression Analysis. Module 2, Session 1. Session 1 will cover Subject Outcome 4.2, Variance and Regression, and Introduction. Learning Outcomes 4.2.1 to 4.2.2, Variance and Standard Deviation. Subject Outcome 4.2, Variance and Regression Analysis, Introduction. Welcome back. This module will focus on Subject Outcome 4.2, which covers variance and regression analysis. Most students should have covered standard deviation and variance in Level 3. Regression analysis, however, is new to Level 4. Because the first subject outcome is not examined, we begin with examinable content for Topic 4 in the second subject outcome. Variance and regression analysis makes up 15% of Paper 2. Let's take a look at Subject Outcome 4.2 and its learning outcomes in more detail. You will find them on page 12 of your subject guidelines. Subject Outcome 4.2. Use variance and regression analysis to interpolate and extrapolate bivariate data. By the end of the subject outcome, students should be able to calculate variance and standard deviation manually for small sets of data only. Interpret the meaning of variance and standard deviation for small sets of data only. Represent bivariate numerical data as a scatter plot. Identify intuitively whether a linear, quadratic, or exponential function would best fit the data. Draw the intuitive line of best fit. Use least squares regression method to determine a function which best fits a given set of bivariate data. Use the regression line to predict the outcome of a given problem. Lecturers often cover the basics of variance and standard deviation at Level 3 and revise and build upon it in Level 4. Regression analysis of bivariate data is new to Level 4. Students can gain some easy marks here as it simply involves following a procedure. Learning Outcomes 4.2.1 to 4.2.2, Variance and Standard Deviation. Measures of dispersion give us information about how spread out the data values in a data set are. Students should already be familiar with several measures of dispersion. The range is the simplest measure of dispersion. It is the difference between the minimum and the maximum values in a data set. However, the range doesn't tell us how individual data values are distributed. The interquartile range is an improvement, as it tells us how spread out the middle 50% of the data values are around the median, but this measure still gives us limited information. The variance and standard deviation are more useful measures of dispersion. They give a clearer indication of how data is spread around the mean using every data value in a calculation. Let's pause for a quick group activity. Discuss in groups and explain as if you were in front of a class. Do you remember how the variance and standard deviation are calculated? What do they represent? Let's look at the formula and definition for the variance. Variance is equal to sigma, the sum of all the values given by the expression that follows. Starting with the first value in the dataset and ending with the last value in the dataset. Xi represents each data value in the set. The mean is subtracted from each value in the dataset. Each result is a deviation from the mean. Some of the deviations will be negative. We square each deviation to get rid of negative values. N is the number of values in the set. After finding the sum of all the squared differences, divide by the number of the values in the set. This calculates the mean of the deviations. So, we can say that the variance is the mean of the squared deviations from the mean of the dataset. Students can find the variance formula on the formula sheet. And now, the formula and definition of the standard deviation. Standard deviation is calculated as the square root of the variance. Standard deviation measures the overall dispersion of the dataset from its mean. A high standard deviation tells us that the dataset is highly dispersed. A low standard deviation tells us that the data is less dispersed. Students will find the formula for standard deviation on their formula sheet. For many kinds of data, we see that data is naturally distributed according to a distribution called the normal distribution. The normal distribution is not part of the curriculum, but is an important part of statistics. If data is normally distributed, then we can expect to see around 60% of the data values lying within one standard deviation of the mean, around 95% lying within 2 standard deviations away from the mean, and around 99.7% of the data within 3 standard deviations from the mean. Let's look at an example of calculating the variance in standard deviation. Simpiwe saved the following amounts of money during each quarter of the year: 10,000 Rand, 12,000 Rand, 8,000 Rand, and 6,000 Rand. Calculate the mean, the variance, and standard deviation. Let's start off with the mean. The mean is equal to the sum of xi over n. We sum up the amount saved from each quarter and divide by 4. This gives us 36,000 Rand over 4, which is 9,000 Rand. So our mean is 9,000 Rand. Let's check our answer with a calculator. In an exam, students are required to do these calculations manually, showing all steps, but it is useful for them to know how to check their answers with a calculator. This will allow them to pick up any mistakes and correct them. We will use the Casio FX82ZA+. For other calculators, students and lecturers can refer to their calculator manuals. First, we need to enter our data. We press Mode and then to Stat to select Statistics mode. We select option 11 VAR. We enter the 4 data values each time, followed by the equals key. When we have finished entering all data, we press the AC button. Now that we have entered our data, we can calculate the mean. We press Shift 1 while still in our Stats mode to get our Stats menu. We select option 4, VAR, followed by option 2 for the mean, followed by the equals key. This gives us 9,000 Rand, which is the same as we had calculated, so we know we are correct. Now to calculate our variance. For this, we need to set up a table. The first column contains xi. The second column contains xi minus the mean of x. And the last column contains the square of xi minus the mean. Once we have calculated column 2's values, we can calculate column 3. Once our table is complete, we use it to find the sum of the final column. Adding 1 million plus 9 million plus 1 million plus 9 million gives us a sum of 20 million. We can now substitute this value into our variance formula. We get 20 million divided by 4, which gives us a variance of 5 million. Now that we have our variance, we can easily calculate our standard deviation by taking the square root of the variance. This is the square root of 5 million, which gives us a standard deviation of 2,236.01. We can also check this figure with our calculator. Our data is still stored, so we can immediately select our statistics menu by pressing Shift 1. We select 4 VAR and then select number 3 for standard deviation, followed by equals, which gives us 2,236.01. So our calculation was correct. We can now easily check our variance figure by squaring the standard deviation. We press the x squared button followed by equals. We get 5 million, so our calculated variance was also correct. Now, work with a partner to solve this problem about computer sales figures. Think about how you'd explain each step to a student. Discuss any problem areas or tips for teaching standard deviation and variance. Let's watch a lecturer working through the solution.
Okay, let's look at the next question. A computer company keeps track of the number of computers each member of their sales team sells. Okay, the figures below are the number of computers each member of the sales team sold during one calendar year. So there we have the figures. It's 17, 19, 14, 16, 11, 18, 12, 23, 27, 29, 32, 34. Let's look at the question. The first question that we have to solve is determine the mean of the number of computers sold per member of the sales team for the year. So, okay, with this question, we are going to look at the mean. And for that, you know how we write that? We put down our x, with a bar x, which is your mean, is equal to, and this is your formula that you will use. So we have the sigma notation, which is the sum of, and then we have our x, right, which is your item, all over n, which is your number of items. Okay, now once we have that, we can then say, okay, the mean, which is bar x, is equal to, we will then say 17 plus 19 plus 14 plus 16 plus 11 plus 18 plus 12 plus 13, sorry, that's 23. Okay, 23 plus 27 plus 29 plus 32 plus 34. And this all over. Now remember, your n is the number of items, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 items, okay, and it will be all over 12. Okay, now we have to add them up. If we add up all those numbers, it will give us 252 over 12. Okay, and then we can get into our answer, which will be the mean is equal to 21. That will be 21. And there we have the mean, and the first answer is solved. So now we look at the second question, which is we have to complete the table that we have here. Now, in order to complete the table, let's just write down the mean once again, just to remind us that we have the mean of 21. Okay? So in our first column, we already put down the items. Can you see there's all the items that was given in the information, right? And in the second column now, right, we have our item. Right here, we have our item. And we subtract the mean, right, from the item. So we have 17, and we subtract from that 17 the 21, which is the mean, which is equal to -4. At first, the students they don't know. Normally, what they do, they will put the 21 first, and then they will say 17. Rather, let them put down the 17 and subtract from the 17 the 21. So now we call this our variance, okay? We call this our variance. The next column we fill in, we look at the variance. Remember, this is now your variance, and we are going to square the variance. So this, in actual fact, will be -4, and we will square it. Okay, and if we do square it, right, we know that the answer to that will be 16. Okay, so this will be your variance, right? This will be your variance, okay, and your variance squared. So now what are we going to do is we are going to do the same for the rest of the information to complete the table. Okay, so now that we have filled in all the information, we are now going to add them all up. So we are going to go through all these items, and we are going to find the sum of all the items. So the sum for all of that will be 252, right? If we add up all our variances, it will always be, by the way, this one will always be equal to 0, okay? When you add them up, it will always be equal to 0. And then we look at the variance squared. We have, when we add them up, it will be 678. And there we have it. We have now completed the table. Let's do question number 3. Now with question number 3, we have to calculate the variance of the number of computers sold per salesman. And here we are looking at the total variance. As with the table, we were looking at the variance of the item with regard to the mean. So let's start. Let's first start with the formula that has been given to you. Now this formula is basically on the formula sheet, and please use that formula sheet while you are doing exercises in class or when the students need to do it at home. So from the formula sheet, okay, we will have that formula as 2, which is your variance, is equal to the sum, right? And the sum of, can you see the sum of this, the variance squared, right here? We get that from there. So it will be the variance, right, squared, okay? And that all over the number of items. Now once you have the formula, the correct formula, you must always make sure that your students have the correct formula before they start substituting. Substituting is very, very easy. So you can show them basically that here we have the variance is exactly the same as the one that you had in your table. That is why we use that table. So, okay, we have 678 all over the number of items, which is 12. Okay, if you divide that into the variance, your answer will then be 56.5, and that's your variance, total variance. Okay, that's question number 3. You guys okay with that? So let's go into the 4th question, question number 4. And with question number 4, here we have to calculate the standard deviation of the number of computers sold per salesman. Once again, just like the previous question, we are going to write down the formula, and the formula for that is the standard deviation is equal to, and we have it, remember here, it is just the square root of the variance. The square root of the variance, which will be the sum of variance over n, and the square root of that. So when we substitute, we will then say, okay, this is the same as the answer that we've got here. So that we are going to plug in here. So that would be the square root of 56.5. Once we are done with that, we quickly calculate, and your final answer for that will be 7.52. And this is our standard deviation, and it will satisfy question 4. So let's look at question 5. With question 5, make a statement regarding the sales success, the sales success of the sales team by using the standard deviation you calculated in question 4. Okay, so right, if you look at the standard deviation, you will see that if you look at here, there's 7 of them that are very close to the mean. So we can say most members of the sales team have sales numbers close to the mean of the team. 7 of them have sales numbers that lie within the standard deviation of 7.52 from the mean. 21, sorry. As a group, the sales team, I think, if you look at 7, it's more than a half, performed well.
Teaching tips. The table method gives students an intuitive understanding of what variance and standard deviation are all about, because they actually calculate the deviation from the mean for each data value. The use of standard deviation becomes more meaningful when you compare 2 different sets of data. It is also useful to show students visually what a data set with a large standard deviation looks like compared to one with a small standard deviation, such as in a simple dot plots like this one. Viewing the data like this also helps students to understand why we need the standard deviation. The mean is more significant if the standard deviation is small. In a very dispersed data set, the points appear to be quite randomly scattered, and they don't support the mean well.